if you see, this is one of the SOC architecture. So you have seen like a processor, assumption, any one of the ARM processors or the SOC itself. The SOC we have seen here. Octa-core SOC. So it is of similar type. But if you see here, how many cores are there? 1, 2, 3, 4, 5, 6, total 6 core processor. This is a 6 core processor. Okay, these are logical cores. That means each core is like a processor. Okay, A7 core. This is an A7 core. So if you see A7, A15, all these are application specific. Okay, A7, A15, these are application specific. So here we have A7 processors, 4 A7 processors, and 2 A15 processors. So all these are connected to a common cache called L2 cache. These two are connected to a cache called L2 cache. Okay, so this L2 cache is actually connected to the interface, a coherency interface. A coherent interface. This is what I am calling it as like CHA protocol. This is actually a bus. Okay, this is actually a bus. Have you heard about AXI bus? I mean APB bus. Have you guys anywhere heard about APB bus? APB bus, AHP bus, APB AXI bus kind of things, guys? Or it is an interconnect. Okay, it is an interconnect. So this interconnect will connect these things to another component. Okay, so it acts as an interconnect. So it acts as an internet component. This interconnect will act as an internet component. Okay, or I can say it like this. So these are the two protocols generally they are going to use here. Okay, so like this processors, the processor components, the L2 caches or all the processors, logical cores is connected to this interconnect. Okay, this interconnect, if you see, this is how it gets connected here. This L2 is connected to this interconnect, this position. Now if you see, there is a graphic subsystem. It is also connected to this top level interconnect. All the DSP subsystem like this, okay, is connected to this interconnect, and this interconnect was connected to the top level interconnect. Here also, application like this, all are connected to this interconnect, and from this interconnect connected to the top level interconnect. So all these IPs, these are IPs. Okay, all these are IPs. This is again connected to the top level interconnect. Okay, if you see all these are IPs, your HDMI port, display port, all these ports, it is again connected to the top level interconnect. So these are some based things like a crypto kind of things, some of the security kind of things. Okay, so it is connected to the top level interconnect. Your wireless subsystem, it is connected to the top level interconnect through internet that was developed inside their modules. Okay, so if you see all these external boards, high-speed peripheral boards, if you see all are max, all are serial communication boards. Okay, so it is connected to an internet, and this internet is connected to the top level subsystem. This is the memory controller. Okay, this is the memory controller. So this memory controller is connected to the subsystem. I mean, one of the internet, and that internet is connected to the top level internet. And my processor, if you see, there is a direct connection between this interconnect to the memory controller. This interconnect to the memory controller. So the things are like if you observe the things, if you clearly observe the things, how many IPs are there? Similarly, that many interconnects are there. Generally, these interconnects are AXI interconnects or AHP interconnects. Okay, AHP interconnects. So nowadays, there is an evolution of these protocols like AXI3, AXI4, AXI5 kind of things. What they are doing is, in AXI3, there are purely AXI signals. Okay? In AXI4, actually, they introduced ES signals inside AXI. Okay, this helps me. So ES, so what is this ES will tell us is it has a coherency signal. The coherency signals we use to do the connections, a kind of transactions or connections between the main processors. Okay, so in AXI, in the next generation of AXI, they will introduce some of the concepts from the CH to the AXI protocol. So now, instead of implementing ECH or ACE, I can directly use the AXI interconnect here, because what and all are the things that request from the CH that is available on the AXI now. So I can directly use AXI here also instead of the coherency or coherency applications, coherency extensible interfaces. Okay, so that is how the evaluation of protocols will generally going to happen. Okay, but if you see where I will use this AMBA protocols is 90% you will use this AMBA protocols as a interconnects. Okay, so all these interconnects are AMBA protocols. Okay, ABB or AHB, AXI kind of things. Did everyone got this, guys? Did everyone got this? Any doubts here, guys? Did everyone got this? So let's see one thing. Here, this processor, okay, want to take data from, let's assume, this USB. Okay. So assumption, there is a data that was there in the USB, and that need to be stored in one of the, let's assume that need to be stored here. Assumption. Okay. So from here, okay, through this interface, my coherency controller will access it. So from here, my processor will access it. So how the things are directly going to happen here? How the things are directly going to happen here is, instead of moving this path, it generally accesses this path. Okay, it is straightforward compared to another internet top level internet. Generally, there is a direct connection between these two. So how the things are going to happen? Is my processor won't involve in all the data transfer. So this is the data transfer from USB to the DDR. So the things are like there is no straight transfer, no straight involvement of this core processor like in one of the cores here. So what it will do is there is a thing called which is not there in the GPU subsystem. Assumption in GPU subsystem only there is a component called DMA. So, did anyone heard about DMA, guys? Did anyone heard about DMA? Direct memory access, exactly. Direct memory access. So, can anyone tell me like what is this direct memory access? Exactly. In microcontrollers and all, we'll see that. So, can anyone tell me what is this direct memory access? I like brief. Okay. Even that is wrong. That's not an issue. Okay. Can anyone tell me what is DMA? Yes. What is DMA? Accessing data directly. The memory which stores in the processor. Okay, accessing data directly. Okay, fine. So who will access from where it accesses? Exactly. Communication without involving the CPU. I can even say like communication or data transfer with minimal intervention of the processor. I can say data transfer with minimum intervention of the processor. That means my processor won't do all those things, but my processor will command, okay, my processor will tell to a component that delegate me, okay, delegate like me, and do the data transfer between two components. So with the minimum intervention of the processor, there is a component called DMA, direct memory access controller, and actually it will do the transaction. It will do the transaction. So what is this minimum intervention is like? The minimum intervention is like my processor will tell like from where you need to take the data and from where you need to store the data. Okay, so it will tell the source and destination address, how much data you need to copy and the things, okay, how many bytes of information you need to take from the source and where you need to sit. I mean, where you need to copy. All this information first processor will dump into the DMA controller. Okay, so based on that, my DMA controller will work. So here my intention was like, my intention in the sense, my processor requires a data from USB 3. So from USB 3. So anything, generally the things here it will work like that. So if a processor requires anything, first of all it will ask its caches, okay, cache. There is a cache memory. Here they have mentioned L2 cache, right? So there is another cache called L1 cache and there is one more cache called L3 cache. Okay, so this is L2 cache. So even near to this, there is one more cache called L1 cache. Let's assume there is one more cache called L1 cache. So first this processor will ask the L1 cache controller, L1 cache, that do you have the data? Let's assume here there is a file. Called SOC assumption. Okay, SOC architecture. So there is an SOC architecture image assumption in the USB 3, the thumb drive I have connected to my laptop assumption. Inside my pen drive I have an SOC architecture diagram. So I try to open that. Okay, so in the meantime, how the things are going to happen, let's see. First, one of the core will ask L1 like, do you have this SOC architecture? L1 tells like, no, I didn't have that. Immediately it will ask L2. It will tell like, do you have any this SOC architecture? It asks like, no, I didn't have. So immediately it will tell to the cache controller that go and fetch that. In the meantime, that was not there in the internal memory also. So let's assume these are the internal memories. Internal memories inside my RAM, okay? Because the hard disk and all are like slush memories compared to the caches. Those are slush memories. Okay? So the fastest memories is like DDR. Okay, compared to the these things, the hard disk and everything, DDR is fastest. So compared to the cache, DDR is still slush memory. Okay, so first of all, it will check like where the data is present. So it will tell like even DDR also not have the data. So what it will do is, okay, now we didn't have all this data. We didn't have the SOC architecture in any one of my subcomponents. So immediately what it will tell is, it will tell to the DMA controller. It will tell to the DMA controller that source address is USB 3. Actually, it won't tell like USB 3 or USB 3. It has a function address. So based on the function address, it will assign the things. Okay. So assumption I'm telling it as like USB 3 something like that. Okay. Source is USB 3. Destination is DDR. Low power DDR. Okay. So low power DDR. Here let's assume DDR. Okay. So you need to transfer. Let's assume this is of 10 bytes. Okay. Assumption this is of 10 bytes. So you need to transfer 10 bytes of data, and the source address is USB 3. Destination address is low power DDR. So immediately what it will do is it will directly comes to this interconnect. Okay. It will directly comes to this interconnect, and from interconnect it will comes into the subsystem interconnect. So from subsystem interconnect it will access the USB 3 directly. So according to the destination, source and destination set by the processor, this data inside this 10 byte will get copied into low power DDR like this. So it will get copied like this. Okay. So from here it will come like this. So from here it will go to this path and it will get stored here. Okay. So once it gets stored here, next. So now my LPDDR has the 10 bytes, or my DDR has the 10 bytes of SOC architecture image. So now my processor will tell to the cache controller to go fetch the data. So immediately the cache controller will come to this memory controller, and from memory controller it goes to the DDR, that means our RAM, and from RAM it will take the data and will store inside L2 or L1 caches. Okay. So from L2 or L1 caches, my processor will access the things. This is how the data transfers will actually happen inside an SOC. So to do that, we require these interconnects. So these interconnects are generally axi interconnects or HV interconnects based on the area. So if you are connecting an interconnect to the processor, we will use coherency because there is a concept called cache. That coherency, there is a concept of cache in the processors. So there we will need to handle the cache transactions, right? So for that reason, they have created a protocol called CHA protocols or ES protocols, where we have a concept of caching the cache transactions, okay, cacheable transactions. Cacheable in the sense, cacheable, smooth cache. There are some cache controller things. So to do that, we require this cache coherency concept. So apart from that, 90% of the area we'll use APB or AHV or AXI. These are the three protocols. We will use in the internet. So did everyone understood how the data transfers will happen here, guys? How the data transfers will happen here? Did everyone understood this? So what is the requirement of AXI? Did everyone understood this? Guys, any doubts here? Did everyone got this? Guys, am I audible? Okay, so did everyone got this? Okay. So that is how important AMBA protocols are. Okay, that is how important AMBA protocols are. So let's see this AXI now, because we know what is APP, we have used APP. So what I will do is I will correlate this APP with AXI and we'll try to understand how the things are there, how the things are there. Okay. So yeah.
Sir, I am confused in AMBA protocol and AXI protocol. Like AMBA protocol is the advanced version of APP, right?
No. APP is one of the protocols in the AMBA.
Okay. Sir, can you briefly explain that what's the difference between AMBA and AXI?
AMBA and
AXI, sir. AXI.
There is, first of all, ARM. There is a company called ARM. Okay. So this ARM has designed a protocol called AMBA protocol. So they designed a set of protocols. Those are called AMBA protocols. So it is actually kind of family, the AMBA protocol family. So inside the AMBA protocol family, okay, there are some family members. Who are those family members? Are like APP is one of the members, okay, AHP is one of the members, AXI is one of the members, AC is one of the members, and CHA is one of the members. So these are all the protocols belongs to AMBA only. Okay. So what this AMBA is telling is like how to access the registers, okay, how to transfer the data in a parallel, in a concurrent manner. Okay, concurrent manner in the sense, not like serially, how the data need to be accessed parallel. This is what the AMBA protocols will tell to us. So generally we use to target a particular registers, okay, or considering the read registers kind of things, or we will use the AMBA protocols as a interconnect. So whenever I am saying AMBA protocols in the sense, APP will come under that, AHP will come under that, AXA will come under that, next AC and CH also comes under that. Got it?
Yeah, yes, sir.
So let's as we know, as you guys didn't know what is this AHP yet, right? So I'm not going into the AHP. So you guys didn't know about APP because you have used APP. So what I will do is I correlate that with the APP, okay, that AXA with the APP, and we will see, we try to understand what the things are actually got advanced in the AXA compared to the APP. Okay. So as I'm talking APP, AHP, AXA, AC, CH, all belongs to the AMBA only. Okay. So AMBA in the sense, it is the name of the family. Okay. There is no specific signals in AMBA. Okay. AMBA has a set of protocols. Okay. So that protocols are like APP protocol, AHP protocol, AXA protocol, AC protocol, and CH protocols. Okay. And there are a few more protocols as well. Okay. So let's correlate the things. Correlate the AMBA APP with AXA. So let's see APP, advanced peripheral bus. So can anyone tell me what are the signals of APP? What are the signals of APP that we have used till now?
The P address, PW data, R data, P connect, and P enable.
Okay.
Yeah.
Next.
And P write, PI for selecting write or repeat.
Okay.
Yeah.
P error. Okay. P clock, P reset. Fine. Yeah, these are the signals we have used, right? Yes. So let's mention that. P clock, P reset, P enable, P ready, P write, P address, P W data, P R data, P select, P error. Okay. These are the signals we have used. Till now, these are the signals we have used. So if you see what and all of this P tells about it. What is this P tells about? Guys, what is that P tells about? APP, right? This is APP, it's a peripheral kind of thing, so that is the reason it is telling that APP. Okay? So it is telling about the APP. Fine. So whenever we have seen P in front of any signal, so we can easily tell that this belongs to the APP protocol. So similarly, for APP we use P as prefix for every signal. Okay. Next, for AHP we use H as prefix. For AXI we use AW, W, B, AR, R. So these five we will use for every signal as a prefix in AXI. So what and all of this AW, W, B, AR, R? So the things are like, I have told you, like in AXI has 5 channels. AXI has 5 channels, 3 for writes, 3 write channels, 3 write channels, 2 read channels. So 3 write channels are right. So this write channel corresponds to handling the right transaction. This read channel corresponds to handling read transaction. So right channel in the sense it's handling the right transactions. So transaction consists of address and data. So those are the 3 channels are like address, write address channel, write data channel, and write response channel. Okay. So next, read address channel, read data and response channel. So here we have 5 channels. So for each channel, we will use these kind of things. Okay? To tell for which channel we are doing. Okay? AR, R. So I am using these prefixes to tell which channel data, which channel signal is actually happening. If I am seeing that AW, I can directly tell like, okay, this belongs to the right address. If I see W, I tell like, okay, right data channel. If I see B, I can say like this belongs to the right response channel. If I see AR, it is tell that I can understand like, okay, this belongs to the read address channel. If I see R in front of any signal, I can tell like, okay, this belongs to read data and response channel. So like that. For APP we have P, for AHP we have H, for AXI we have AW, W, B, AR, R. So these are the 5 things, and each thing corresponds to the respective channels. Okay? Right address channel, right data channel, right response channel, read address channel, read data channel. So these channels corresponds to do the transactions of the respective things. That means right channel in the sense, in this channel we only do write transactions. Read channels in the sense, here we will only do read transactions. Okay, that means transaction in the sense address plus data. In AXI, response also get included here. So right channel in the sense it has address, data, response. Read channel in the sense it has address, data, and response. Okay, so you may ask like, we have 3 channels in the writes. Why we have only 2 channels in the read? Why not a separate read response channel? Just like read response channel, write response channel. Why can't it be like read response channel as a separate channel? Why instead of matching those 2 things, why we didn't have separate response channel? This is one of the important question if you get this. Okay? In 90% of the interviews you may get this question as well. Okay? I will tell you, I won't tell right now, because to understand this, you need to learn some more things regarding this AXA channel. Okay? So once we discuss all those things, then I will tell you the answer for this question. Okay? So why read channels have only 2 channels? Why write has 3 channels? Okay? I will tell you there. Okay? So for that, we need to understand how the data transfer is happening between master and slave. Okay? Then we can understand the concept of this by 3 here, by 2 here. Okay? So did everyone understood this, guys? P, H, A, W, W, B, A, R, R? So the things are like, yeah. So now let's observe. We have seen that P, okay, P is used for the APB. So here we have these signals, we have seen these signals. So P clock is used for clock. It's a clock. It's a reset. Enable, here they use the enable ready to do the handshaking. To do the handshaking, they have used enable and ready. Okay. So right, this is exactly the same as right read. Okay. Here is equal to 1 is a right transaction, here is equal to read is a free transaction. And as assumption 32 bit, it's a 32 bit. And PW data assumption is a 32 bit. Okay, I'm taking it as 32 bit. Okay. So I can send 32 bits at a time. That's it. For each transaction, I can send max of 32 bits, not more than that. Okay. So R data, this is also 32 bit. So in any transaction, I can receive max of 32 bits, not more than that. P set, this is a single bit. Okay. And error, if any wrong slave got selected, this error will get. Okay. So these are the signals we know. So by seeing the P itself, we can tell like, okay, this is the APB. Okay, this is the APB. And here data, PW data is of 32 bits. Okay. So let's do the correlation. Okay. APB, PW data and PR data plus 32 bit plus 6. So for each transaction, I can send or get 32 bits only, not more than that. 32 bits only, not more than that. Did everyone got this, guys? 32 bits only. So this is the basic protocol once we have learned in Verilog from Verilog. So now let's see AXI. AXI has a signal called say W data and R data. Okay. W data and R data. Okay, if you see W data, this belongs to this W, right data channel. R data, R, this belongs to read data and response channel. So W data and R data, fine. This AXI has a signal called W data and R data, which is exactly the same as PW data and PR data. Okay, so PW data and PR data. So in such kind of situations, I will take okay, here only data as 5 bits. Now here the things are like it will make the things deviate from APB. So AXI supports bursts. AXI supports burst branches. So each transaction can capable of sending more than 32 bits. That means here in the previous example, APB 100 bytes of data on a 32 bit bus. So on a 32 bit bus in APB, I need to send 100 bytes of data on a 32 bit bus. So it requires 100 divided by 4. Right, 4 bytes. This is bytes. That means 32 bytes. So this results in 25 transactions. Whereas in AXI, I need to send 100 bytes of data, the same 100 bytes of data on a 32 bit bus. So now my AXI will ask me like, no, you need to give some data. 1 minute, guys. Okay, so I need to send 100 bytes of data on 32 bit bus. So AXI will tell me that, okay, the information is not sufficient for me. You need to tell, okay, how many transactions, that means how many bursts I need to do. That means how many such 32 bits I need to send. It will ask like that. Okay, it will ask like how many such 32 bits of chunk data I need to send. Okay, so that is what we call it as a length. Burst length. We call it as a burst length. Say AXI3 supports 16. Okay, AXI3 supports 16. Let's assume. So burst length is 16. That means my AXI, right transaction, my AXI now capable of sending 16 such 32 bits in a single transaction. So that 25 transactions, that 100 bytes of data to send to slave. So that 100 bytes of data requires only 2 transactions, 2 AXI transactions. If you ask me, 2 AXI transactions. So now how I tell that 2 AXI transactions is like, see, so I tell like burst length is equal to 16. That means burst length is equal to 16 in the sense, what it is telling is, I can send such 32 bits, 16 32 bits. That is what this burst length is telling to me. Okay. So we will see what is this burst length and everything. Okay, I am not introducing all those things right now. Okay, so I am just introducing this burst length. So it tells like how many such kind of data items, the data items need to be sent in a single transaction. This burst length tells like how many data items I need to send in a single transaction. So I am telling like 16. So now my data items is of 32 bits. So I can send 16 such items. Okay, 16 such items. Okay, so I can send 16 32 bit items. Data items. Now total data items are of 25. If you ask me, total data items are of 25. Okay, so to send 25, 2 transactions are right. Did everyone got this or do I need to repeat? Did everyone got this, guys? Did everyone got this? Okay, so I will put some notes. Burst length. What is burst length means how many data items that I need to send, the master need to send. Master is sending on a single transaction. Okay, master sending or receiving. Okay, or receiving on a single transaction. So this is what the burst length means. That means in a single transaction, I am sending 16 32 bit items. In yesterday, yesterday I have drawn that. Yeah, this one. 8 right? 1 minute. So this is one data item. This is one data item. This is one data item. 1, 2, 3, 4, 5, 6, 7. Total the bus length is 7. Okay. Total the length is 7. That means inside this single transaction, okay, this single transaction, it is sending 7 data items. Each can capable of 32 bits because I am taking W data as 32 bits. So each data item is of 32 bits. Okay? Each data item is of 32 bits. Okay. So there is a relation. Like it will send the bus length. You may ask like where this bus length will present. It will come under address channel. Address and control information will get through address channel. So based on the control information and addresses, my data channel will transfer the data. Okay? So according to the data channel, according to the data it receives, slave will give the response. So this is how the things are going to happen. So while issuing this address, the master also communicate to the slave like how many data items are coming. Okay, what is the length of each data item, and everything it will convey in the address channel only. It will convey in the address channel only. Did everyone understood this, guys? So, sir, what if burst length is more than 32 bit bus? Burst length is actually not a 32 bit bus. Burst length is a 4 bit. Okay? It is a 4 bit and it will change from protocol to protocol. From ASA3 to ASA4, it got changed. Okay, like there is an improvement happening there. Okay, so the things are like as we are going the ASA 3.0, we are doing the ASA 3.0. So ASA 3.0, it is a 4 burst length is a 4 bit channel. So a 4 bit signal. So 4 bit signal in the sense it can take 0 to 15. So total 16 transactions it can take. Max of an ASA3 can do 16 transactions, 16 transfers, or I can say 16 data items that are going to send in a single transaction. Did you got this, Jyoti? Yeah. So any other doubts, guys? Any other doubts? As we are not going into the signals list, so let's not. Yeah, anyone has to?
Hello.
Yeah.
So can I elaborate the calculations in ASA transfer flow? Which is 100 bytes just takes 2 8 stop.
Yeah, 2 transactions. Okay, I'll tell you how the things are going to happen. Okay, so 100 bytes. Did you got this 100 bytes 25 transactions in APB?
So yeah, I got it.
Okay, now what I will do is each transaction consists of 32 bits. Here, each transaction consists of 32 bit data. Single 32 bit data. Single 32 bit 32 data. In W data plus PW data plus. So now here what I will do is in AXI, based on the burst length and burst size, we will do the transaction. Say assumption. Say I am giving some of the signals right now to understand these things. To tell these things, I am giving some signals. Okay. So let's not think like I don't know all these signals right now. Just take this like this. Okay. Address is equal to let's take like 32 bit 100. This is a normal address. Okay. Next burst length is equal to let's take it like 15. Okay. Burst size is equal to 2. So what it is saying is 15 in the sense 0 to 15. That means total 16. Okay. So here 2 means 2 to the power 2. That means 4 bytes. So what this burst length is telling is 16 data items need to send in transaction. In single transaction. Okay. This is what it is. Each data item, burst size tells like each data item is of 4 bytes. Each data item is of 4 bytes. So this is what it is telling. So now this is a single transaction. I am talking about single transaction. Okay. The transaction started as is 100. Okay. Transaction started as is 100 and burst length is like total 16 items. And burst size is of 2. So whenever they have given such kind of 2 for the sizes, we need to do the 2 to the power of calculation. Okay. We need to do the powers of calculation. 2 square. That is equal to 4 bytes. So it tells like 4 bytes of data. Okay. Need to be sent in each data item. Okay. In each data item, I need to send 4 bytes of data. Okay. 4 bytes of data. That is what it is telling. So if you calculate 64. So if you see 64 bytes of data is actually going on a single transaction. Got it? Yeah. So that means I do 16. So I can send 16 data items. I can say in AXI 3.0, I can send max 16 data items in a transaction. Okay. Each data item can be of 2 to the power of burst size 2 square, that is equal to 4 bytes. That is equal to 32 bits. Okay. So for a single transaction, total bytes I am sending is total bytes is equal to 16 into 4, 64 bytes. So if you see 36 bytes are remaining, and these 36 bytes are sending in the next transaction. Okay. So 100 minus 64. These 36 bytes of info or data will send in next transaction. So to send 100 bytes of data in an AXI transaction, in an AXI protocol, using AXI protocol, with length is equal to 50 and size is equal to 2, we just require 2 transactions. Got it? Did everyone got this, guys? Did everyone got this? Let's not get into all these calculations. If you are feeling confused right now, let's not get into this calculation, because from next tomorrow or day after tomorrow, we start doing this calculation then every day. Okay? We start, because once we start the signals, AXI signaling. Okay? Once we start learning about the signals, from that day onwards, we'll start doing all these calculations. Okay? So let's not get confused here. If you are feeling confused, let's not get confused. Okay? So, guys, this is how the two transaction concept will end up. To get these two transactions, it depends upon length and size. Length and size. Okay? Let's take like if it is 3, size is equal to 3. If size is equal to 3, 2 cube, 8. So 8 bytes. That means for every transaction, or for every data item, I can send 8 bytes of information actually. So for that reason, my W data bus also need to be supported 8 bytes. That means 32-bit is no longer supported. I need to upgrade that to 64-bit bus. Okay? I need to upgrade that to 64-bit bus. Sorry, I need to upgrade that to 64-bit bus. So if that is the situation, 16 into 8. So all 100 bytes of data. So it is like one transaction is enough to send all 100 bytes of data. Did everyone got this, guys? Did everyone got this? Did everyone got this, guys? Yeah. Okay. So that is what the things are like. So that is how the advantage of using that is what the advantage that we are get through the exit. So, but if you ask me the same things like how many clock cycles do I require? Again, I will end up with the AHB only. How many clock cycles that AHB requires? The same clock cycles I can end up here. I am end up here in AXI. But the concept is I am getting a lot more convenience here. Like there is no dependencies on writes and reads because of the introduction of the channels. There is a complete isolation between writes and reads. Okay, I can do a concurrent writes and reads. Okay, like that. There are some more advanced features. Once we come there, we will discuss that. Overlapping, out of order, in order, interleave. There are some advancement concepts are there which was not supported in the ABB or HP. Okay, so these kind of advancements are there in the AXI. Okay, so that makes me AXI more helpful in many kind of situations. And the next thing is this helps me to increase the performance as well. So did everyone got this point, guys? Did everyone got this point? So till now, any doubts? Till now, any doubts? Okay, no doubts? Okay then. So let's start correlating. As we have seen only one thing, the W data. So let's start correlating. Similarly, T clock is there. There we call it as an A clock. Okay, P reset, there A reset. P enable, we call it as a valid signal. Okay, it is these two are used for the handshaking signal, right? There in AXI, we use valid ready. Okay, valid ready. Okay, next P write. We use write read. Okay, but if you ask me, there is no such kind of exact write read signal in the AXI. Okay, next address, same address, but the P will going to change and the AW and AR will come. Okay, because address we issue in address channel only. There are two address channels. One is for write and one is for read. So I will get AW address, AR address. Okay. Next, W data, R data. So data, this will come from the data channels. So there are two data channels. One is for write data channel and one is for read data channel. Write data channel, I call it as like W data. Read data channel, I call it as like R data. Okay, so next, select, no, I didn't have any such kind of signals. So there are some, we didn't have such kind of signals in AXI 3.0. Okay, and apart from this, we have a lot more signals. Okay, we have a lot more signals. Let's see. APV does not have a concept of channels. APV doesn't have concept of burst. So AXI have the concept of channels and burst. Okay. So this burst helps me to send multiple data items to send in a single transaction. Okay. Single transaction. So this is what the burst means. Multiple data items that are going in a single transaction. This is what we call it as a burst. Okay, burst is a group. In a group, I am sending the data. So that is what the burst means. Okay. So that concept of burst was introduced in the AXI. Okay. That was not there in the APB and HP. Okay. So that was not there. That was for worst case scenario, that was not there in the APB. Okay. That was not there in the APB. So as we are strictly correlating with the APB, let's stick for the APB. Okay. So it doesn't have the concept of burst. APB doesn't have the concept of channel. So if you remove these two things, there is no much differences between APB and AXI. So these two makes the separate from the AXI makes a separate from the APB. That means with the introduction of these two things, my AXI is completely different from the APB. That means it has a lot more flexibility. Okay, lot more flexibility to do all the transactions, to do multiple transactions. Okay, so these are the things. Next, what are the things are like? Correlating protocols. Fine, this we have just discussed. Okay, so let's see. Okay, so what was newly introduced? What was newly introduced in the AXI? First of all, I am comparing with the APB. So as I am comparing with the APB, burst is newly introduced. Channels are newly introduced. So I am talking about burst. Burst consists of burst length. Just now we have discussed what is burst length. Burst length is how many data items I need to send in a single transaction. So it tells the numbers. Okay. Burst size. So each data item, how much size I need to send. Okay. Next, burst type. How the burst actually, I can say how the address is getting implemented. That is what this burst type is telling about. All about this. So like the burst types are of pretext fixed, implemented, wrapped. So these are the things we have. The burst types, fixed address, implementing address, wrapping address. So we will discuss what is this thing. Okay. So if you see, these are the three new things. That was introduced in the AXI. This was not there in the APB. But this was introduced in the AXI. Next, channels was not there in the APB. Channels was newly introduced. in the AXI. Right address channel, right data channel, write response channel. We need to remember all these things, guys. Okay. Read address channel. Read response channel. Read response channel. So we need to remember these channels. These are important. Even if you enter in English, even if you go to an interview, they will ask regarding these channels. They will ask regarding this plus worst case scenarios. Not only worst case scenarios, 90% they will ask you to do the calculations of the map. Okay. Okay. We will discuss that. We will discuss how to do the calculations and all with detailed, in a detailed manner. AR. So as of now, you will feel like what is this, why these channels and all. Okay, as of now, but by the end of this training, you'll feel like axi is the easiest protocol. You'll feel like okay, axi is the easiest protocol. What's there in that such complexity and all, you'll feel that. For that, what you need to do is you need to adjust to this nomenclature. Like what is this address? First of all, you need to understand what in address channel what is going on, in data channel what is going on, in response channel what is going on, in read address channel what is going on, and read data and response channel what is going on. So if you understand that, understanding axi protocol is a lot more easier. The new advanced features and everything, those are easier. Okay? How the things are happening and all. This axi is telling to us, that advanced features is telling to us that what we need to understand is what is the importance of each and every channel. That is what the important point we need to understand. So once we understood these channels, then there is a dedicated signals for each and every channel. There is a dedicated signals for each and every channel. So that dedicated signals, okay, is used to communicate to the slave by the master. Okay, to slave by the master. So this is what each channel is trying to tell. Okay. So let's do a brief here. Write address channel. This is used by the master to convey the double the data, the right data info to slave. Okay. Next. In this channel, master sends the data to the slave. In this channel, slave sends the response to the master. Okay. In this channel, master sends the address and control info to slave. I can say to convey right data info or address and controls info to slave. Here, in this channel, slave sends the data and response to the master. So these are the 5 channels. These are the 5 channels axi uses, and axi will revolve all around these 5 channels only. Okay. Out of that, 3 for writes, 2 for reads. This need to be remembered. Next. How multiple channels? Okay, fine. 4 sided and axi. Okay, this is already we have discussed. Okay, 4 sided and axi protocols. Okay. Handshake. Fine. So let's discuss what is that usage of channels, or how these channels helps in the axi protocol. How channel helps in the axi protocol? Let's take like I have 5 channels. So I have 5 channels. Okay. 3 write channels, 2 read channels. So why I am repeating this many types is this is important. Okay, 3 write channels and 2 read channels. So if you see 3 writes and 2 reads, inside the 3 writes and 2 reads, okay, how we use that and what exactly this is taking to? It's like, let's take write address channel, data, response, read address, read data channel. So here, say sending transaction A, okay, 0 nanosecond, or make it like 10 nanoseconds. Okay. Sending transaction B data, okay, 15 nanoseconds. Slave sends transaction 3 response, okay, 20 nanoseconds. Master sending transaction A address, okay, 10 nanoseconds. Slave sends transaction E data and response, say 15 nanoseconds. So by seeing these lines, guys, what you have understood? What you have understood by seeing that lines? Overlapping, okay, fine. Okay, overlapping transactions is happening, okay. Okay, next. If you see all these transactions, all these channels, they are not talking about the single channel, single transaction. All are happening different transactions. Transaction A, transaction B, transaction C, transaction D, transaction E. So that means all are happening concurrently. All are happening concurrently. Did everyone understand this, guys? All are happening concurrently. So overlapping results, that is telling the concurrency. Okay. So all are happening concurrently. The concurrent nature is the important thing in the axi. So that channels brings that to me. That the channels brings back to me. My response don't need to depend upon the W data channel or address channel. Okay, so so while it is running current transaction, my slave can give response for the previous transactions also. Okay, so there is no dependency. There is no dependency. All are independent. All are independent. All are happening simultaneously. Okay, got it, guys? Did everyone got it? So that is the advantage of having multiple channels. Okay? Having advantage of multiple channels. So without this multi-channel concept, I can say A size of noise. If still AXI has a single channel, then we don't need to learn all these things. Okay? So that multi-channel support brings a lot more advantages in the AXI. Okay? So if I have multi-channel, each channel has individual signals. Each channel has individual signals. So based on the signals, that channel will drive the respective data. That channels will drive the respective data. Based on the data, slave will respond. Based on the data, the slave will respond. Okay? So here, with the help of multiple channels, we can achieve the concurrency. Without multiple channels, we can say A size of use is of no much use. AHB is enough because apart from AHB, we are introducing this channels. So if there is no channels in the sense, AXI is no much of use. Okay? So this multiple channels is what making the AXI different from the AHB and AP. Okay? So with the help of these channels only, we can get the implement the advanced features called of the AXI. Say overlapping, out of order, interleaved. Actually, we discussed these two things in our SV sessions. Actually, folk join, and I have told you regarding these two things. Did anyone remember that? We have discussed on that day. Out of order transactions, overlap transactions, kind of things. Folk joiner, we use folk joiner to attain that. Okay? So that is where we will learn those overlapping out of order in AXI. Okay? So with the help of these channels only, I can implement these advanced features. Without this, I can't able to implement this. With the help of these channels, and there is another signal called ID signal. With the help of these two things, I can implement this. If these two things are not there, okay, I can't able to implement this concurrent behavior. Okay? Here we get concurrent behavior. I can't get that kind of concurrent behavior. Okay? So that is the importance of the channels. Okay? So we can achieve the concurrency. The first thing is we can achieve the concurrency, and this is the really important point. With that concurrency, we can implement the advanced concepts called overlapping, out of order, and interleaved. Okay? And this makes me to send the data is okay. To send the data, if you see, data has a separate channel. Address has a separate channel. In this channel, master sends only address. It won't send data here. In this channel, master sends only data. It won't send address and everything. Here, slave will send only response. So if you see, we can say like, if for example, if I want to see the data, we can directly go to the data channel. If I want to see address and control information, I can go to the address channel. If I want to see response, I can go to the response channel. Right? I have a segregation of all the signals. So with the help of this channel, I can segregate each and everything. Okay? And based on that, we can make the debug easier. It helps me to debug also. So if W data is not getting corrected, so I can go there and I can check W data what is happening. So if you ask me in such kind of perspectives, the channel also helps me to debug things. Got it, guys? What is the advantage of the signals? Channels, multiple channels. So multiple channel concept was introduced in the AXI. So what is the advantage of that is concurrency. That is the important thing. Okay? That is the important thing. So now next. Ports added in AXI, I just discussed. Okay, fine. AXI channels. Ports channel. Just we have discussed right now. Just discussed the WBRR. Okay. So let's understand these two things. After understanding this, we can get an answer for this question. The question I have is why 3 write channels, 2 read channels. So for this question, we'll get an answer for that. So for that, let's go to the spec. AMBA protocols. I have somewhere stored AMBA here. Yeah, here it is. AMBA XI, exactly. Okay, here we have, this is the basic protocol. A very basic signals. Signal description. Yeah, this is read. First of all, let's try to understand this. Okay. It's seen also. Pretty much. So see. So if you see this, guys, this is the master interface. Assumption this is the master. This is the slave interface. That means slave. That means this might be a interconnect also, or this might be a direct master and slaves also. Anything may have. Okay? This might be an interconnect, or this might be a direct master component. This is an interconnect, or this might be a direct slave component. So here how the things are going to happen. This is what the write address is. Write address channel, write data channel, write response channel. So in the write address channel, address and control information was sent to the slave by the master. So this slave will capture this address and control information and will get stored in the internal memory of the slave. Okay. After that, this slave will actually try to go through this. What and all master is sending. Because I told you, right, master will send only one address. The rest addresses need to be calculated by the slave. So that is the reason master will send address and the starting address and rest information. How many such kind of bursts are happening? What is the burst size? What is the burst length? What is the type of burst? Okay. So what is the security that was provided to that data and everything? It will send. It will send inside this address and controlled information. Okay. So after getting unleashed, this master will send data, write data through W data channel. Okay. It will send the data. If you see these are going in a burst, let's assume how many data items are there, guys? So how many data items are there? So there, how many data items are there? Four data items, right? 4 data items. That means 0 to 3. I can 4 in the sense 0 to 3, right? So if they give length as 3, we need to add % to that. Length as 3 in the sense in their perspective 0 to 3. Okay. So we need to add % to that. So that means this control information, address and control information, it has AW length. AW in the sense write address, length in the sense burst length. So here it is taken as 3. Burst length. What is meant by burst length? We have just discussed. Burst length in the sense how many data items I am sending in the write data channel in a single transaction. Okay. So in a single transaction, how many data items I am sending? So as AW length is 3, that means 0 to 3. Total 4. So whenever they have given a length, add +1 to that. So 3 + 1 is equal to 4. So here we have 4 data items. 4 data items that is actually happening. Okay. So now there is one more signal, AW size. AW in the sense write data and the size. Assumption 2. That means 2 to the power of 2. That is equal to 4 bytes. This is what we have seen. That means each data item is of 32-bit length, 4 byte. This is 4 byte, this is 4 byte, this is 4 byte, this is 4 byte. That means it is sending 32 bits of information. It is sending 32 bits of information. So that all the information, all this length, size, type, and everything is the part of address and control information. So all this was sending address and control information. So once my slave will get all those things, my master will just drive the data in the write data channel. In the write data channel, my master will drive the data. Okay? So all the data will get stored inside the memory of the slave. Okay? So once all the data got stored, my slave will give a response. Like it will say like, okay, there are data was not received properly. Okay, so or else we can say like data received properly. Okay, response. Okay, X okay response. That means exclusively transfer successfully done. Okay, there is a transfer called exclusive transfer. We'll discuss that. Okay. Next slave error. This slave. I mean, you are targeted a wrong slave. Okay, or a decode error. So there are some errors. We'll discuss all these things. What is slave error, decode error, okay, what is that by okay, X okay. All those things we will discuss in a detailed manner. Once we start discussing the channels, there we will discuss all those things. Okay, so let's assume there is a response that was sent by the slave to the master. Slave to the master. That means this tells like what this response contains is it can tell like data transfer successfully. Data transfer success or failure. So this is what a write transaction consists of. Did everyone got this, guys? Did everyone got this? Did everyone got this? So as of now, I introduced channels, burst, okay, channels and burst. So we have seen there are 5 channels, 3 for reads, 2 for writes. Okay. Next, I have introduced burst. What is meant by burst? Burst in the sense multiple data items in a single transaction. So that means there is a group of data items that is going on in a channel. Okay. So for that, I am telling like how many data items need to be sent. How much data each data item consists. Okay, all this information will send in the address channel only. Okay, will send in the address channel only. That is also we have just discussed. Next, what and all are the things that is there? What and all are the things that was there? The things in the sense that burst length, burst size, and everything related to the burst. That is a part of address channel. Okay, so what and all are the things that master need to be conveyed to the slave regarding the W data or R data? All that information was placed in the address channel. Okay. Did everyone got this, guys? Did everyone got this? Did everyone got this? Any doubts till now? Any doubts till now? Okay, so let's save this and let's see read channels also. This is read. So here, master read. If you see, this is read transaction. This is about read transaction. Read transaction. Read transaction is a slave need to give the data. Slave need to give the data. So master interface. This master interface. First of all, guys, in memory. Okay, how reads are happening? In memory, the project we have done in Verilog and system Verilog, how reads are happening? First, master issues which channel? Which signal? Value. Okay, handshaking done. Assumption handshaking done. After that, write it is equal to 1. Assumption write it is equal to 1 tells the write transaction. Next, what master will issue? Address and data, right? Address and data. Because write transaction itself, master need to give the data to the slave. So for that reason, it issues address and data. So what about the read? Now handshaking done and write it is equal to 0. So what and all of the signals my master will issue? Guys, which signals did master issues in read transaction? Tell me what is meant by reading? What is meant by reading? Slave will give data. So which data slave will give? It will give random data. Which data it will give? My question is, which data it will give? Master performs writes, okay? Capture data. So the capture data, okay. The address and data sent by the master. Okay, whatever the address and data that was sent during the write transaction, that was getting stored. So how this data is getting stored? Tell me how this data is getting stored. On what basis the data is getting stored? Where this data is getting stored? Exactly, based on the address, it will store on the registers or not registers. It's on memory. Okay, stores on the memory. Okay, slave memory. Okay, on slave memory, based on address, it will get stored. So now tell me, with this conversion, now tell me which data my slave will give during the read transaction. R data, it will give R data, okay, right, it will give R data. So, what is R data? Like, for example, my master performs 5 write transactions, okay. Now, my master is doing the read transactions, okay, 5 read transactions. So, based on what, my slave will give the R data? Based on address, exactly, based on address, my slave will give the R data. It won't give the random data, okay, master sent 5 transactions during read, I won't give the random data, right. Master will send the address information. Okay? In memory also, if you go through that, based on the address only I am getting the R data. Without address I can't get any data. I can't get any data since I may get a random data. That is what I'm not, I don't want such kind of behavior, right? So based on the address only, what is all of the slave location? For example, at 100 location, there is a data that data my master requires. So master will send the address as 100. So immediately slave receives that, okay, master is asking the data that was stored in 100 location. So slave will put the data in the R data and my master will take that. Right? So based on the address only, everything is going to happen. Did everyone got this, guys? Did everyone got this? So the address information is very much important. For any transaction, address is very important. Remember this. Okay, based on the address only, everything is going to happen. Okay. So here, this is the read transaction. So here, to read the content in the slave, master need to tell the address. At this particular address, what and all of the data is there, send the data to me. That is what my master is telling. So for that reason, it has a dedicated read address channel. So in this read address channel, my master send the address, burst and everything, all the control information. Okay, burst length, burst size, burst types, okay, IDs and everything. Everything it will send here, and that is getting received at the slave side, and the slave will go through that, and whatever the addresses and burst type and everything, based on that, my slave will put the data on the R data layer. So R data layer. If you ask me, here we have only two channels. In reads we have 3 channels. So you told like, okay, this is the read data channel. In this channel, response also getting included. This is what you have done just in a moment back. So why in the sense, I am telling this answer for now. I am telling the answer for that question. Okay. So we have gone through reads. In reads, master is sending the address, corresponds to that address. Slave is giving the data. With each data, it will include response. So what is this response is telling here is? So you ask this data, I have sent this data. You ask this data, I am sending this data. Receive that. You ask this data, I am sending this. So I am sending this. That is what it is telling. I am sending this. Okay? It might be another transaction. Whatever the address that was sending by the master, that was not available. That was not available. In such kind of situation, it will tell like some kind of response. There are slave errors, there are okay errors, there are okay responses, there are some kind of responses. That response is going to happen here. Okay? So if you ask me each and every data, there is a response included. Previously, that is not the situation. There is a dedicated response channel. Why there is a dedicated response channel here? Why not? There is no dedicated response channel here. Is, if you see, this is the right transaction, right? Who is sending address information? Guys? In right channel, in the diagram that I am showing, who is sending the address information? Master. Okay, fine. Master is sending address information. In the right transaction, in the same diagram, who is sending the W data? Master is sending the W data, right? Address and data is sending by the master. Okay, fine. Who is sending the response? In right transaction, who is sending the response? Slave is sending the response, right? So in the 3 channels, 2 channels are completely used by the master. Master is putting the data and slave is receiving the data. That's it. Those are single channels, those are single direction channels. Whereas the third channel, the response may be given by the slave. So as these channels are single unidirectional channels, so I can't communicate using the same channels. That is the reason I have a dedicated response channel in the right transaction. Did everyone understood why I have a dedicated response channel here? Because slave need to confirm the response, then whether it received or not. So that is the reason my slave will use a separate channel to send the data. Data instance response in the right response channel. Now let's see the read transaction. In the read transaction, who is sending the address? Master is sending the address, right? Who is sending the data? Slave is sending the data. That means my slave is using one channel. With the help of that channel, my slave is sending the data. Right? So anyway, one channel is used by the slave to send the data. So there is no use of again introducing a separate response channel here. Anyways, my slave is sending. Right? If I introduce one more channel, it will become complicated again. I need to take consideration a lot. The things are like, anyway, I am using one separate channel to send the data. So why not include that response? Because that response, in the sense, to send that response, I need to do handshakes again. So why all this unnecessary complication thing? Anyway, that handshakes are happening in the slave read data channels only. So why not I include the response there? Response is a single signal. It's a 2-bit signal. So why can't I include that 2-bit signals in the read data channel? Did everyone understand this concept, guys? Previously, in right channels, in the right transactions, 2 address and data is coming from the master only. That is the reason slave uses a separate channel to convey the response. Whereas in read, one channel is used by the master to convey the address, the second channel is used by the slave to send the data. So now we are taking the advantage of this read data channel. The slave is using the second channel, so we will introduce the response signal inside the channel. Got it? Got it, guys? This helps me to reduce the retransaction time. One channel, one cycle will get reduced. Or else what will happen is I need to do the handshaking first. After that, I need to send the data. I need to send the response. So that response sending and everything requires one clock cycle. Because at every passage of clock only, right, we are driving, so it is waiting for the next passage of clock. So one clock cycle is unnecessary waste. Did everyone got this, guys? Did everyone got this? Any doubts here? Why writes has 3 channels and reads has 2 channels? What kind of different responses that slave providing 2 different channels? Fine. Actually, there are 4 different types of responses. OK response, XOK response, slave error, and decoder. Okay. OK in the sense everything is fine. So everything is fine. There is nothing wrong happened. XOK in the sense there is a transaction called exclusive transaction. There is a transaction. There is a kind of transaction called exclusive transactions. So if that exclusive transaction was performed fine, then XOK will appear. Okay. The response will become XOK. Next, slave error. There are lot more things to consider, like wrong slave selected. There is no slave at all. The wrong slave selected. No slave means that is decoder. Okay. There is wrong slave selected. Overflow, underflow. There are some concepts out there. Overflow, underflow, memory overflow, memory underflow concepts. Memory overflow, memory underflow. These comes under slave errors. Okay. Next thing, decoder. If there is no slave itself, that means my master is targeting a slave where there is no slave at all. There is no such kind of slave. Then we will get a response called decode error, because you have decoded wrongly. There is no such kind of slave here. So my interconnect will give this kind of response to the slave. So these are response to the master. So these are the 4 responses we have. Anyway, we will discuss that once we come to the response sequence. Okay? Response channel sequence. Okay. So did everyone understood this, guys? Did everyone understood this? So we have discussed how the transactions are happening, how the right channel transactions are happening, how the read channel transactions are happening. Transactions in the sense, first in address phase, address is coming. That means master is sending address. In the data phase, master is sending, data channel, master is sending write data. In the response channel, slave is sending the response. So this is what the right transaction means. Okay. Now in read address channel, master is sending the read address, that means address to the slave, corresponds to this address. Slave is sending data and response in a read data channel. So this is what the read transaction. Is. So now let's put this onwards. So writes has 3 channels and reads have only 2 channels. In writes, address and data was sent by the master. In writes, address and data was sent by the master. So slave uses separate channel to give response. In reads, address is sent by the master. Slave will use the read data channel and sends the data. So we will include the response also inside this channel only. As slave is already using a channel, so we will introduce the response channel, response signal in the same channel. This will save time. This will save the time. One profit. So here there is, if you see here, all the channels. This is address and data. 2 channels was used by the master only. So this is the only channel that is used by the slave. Here already a channel is used by the slave. So that is the reason inside that channel only I am introducing the response. I hope everyone got this. So next. Channel handshaking. Okay, so I will quickly tell what is this handshakings. Okay, channel handshakings, and from tomorrow's session we will start seeing this address channels. Okay, but the handshakings are like straightforward. Channel handshakings. So we use valid and ready to do the handshakings. So we have 5 channels. So we have 5 sets of handshakings. Right reads. Right address. Inside that we use AW valid. Okay. Next. Right data. W valid. W ready. Next. Right response.
चलो जी, चेक करके मुझे बताना, मैं लिख रहा हूँ कि आपके
कितने
का है। ठीक है। ये जो वैल्यू आपके सामने लिखी हुई है 6.66% का 8 गुना होता है। इसको हम 8/15 कहते हैं। ये क्या है 200% plus 62.5.
So these are the signals. These are the signals we will use. That means let's take a look. This is master and this is slave, and we are doing a write address channel. Write address channel. This is master. This is slave. So this is the channel. So now tell me guys, who will issue valid, who will issue ready? As we have knowledge on handshaking, we are doing that from memory. So let's tell me, let's tell guys who will issue valid and who will issue ready. Valid master, ready slave. Master will issue valid, right? So here, this is AW valid, and this is AW ready. This is AW valid. AW ready, fine. So now master issues valid, when slave issues ready, automatically handshake will happen. So handshake will happen, all the data will get transferred at that time. Did everyone got this guys? Did everyone got this? Okay, so let's say this. AW handshake. So now, write data channel. Master, slave. This is the right data channel. So, right data channel. Now tell me who will issue valid and who will issue ready. Who will issue master? Sorry, who will issue valid and who will issue ready? Guys, who will issue valid? Who will issue ready? Master valid. Because this is the right transaction. Master need to give the data. That is the reason master need to issue valid. So who will issue ready? Slave, right? Obviously it is slave. So from master side, valid accepted. From slave side, ready accepted. So this is W valid. This is W ready. W handshake. So now the third right channel. Right response channel. Master, slave. This is the channel. Now tell me, in right response channel, who will issue valid and who will issue ready? I got two different answers. What about others? One is master ready, slave valid, and after telling the master valid, slave ready, and Jyoti is telling the slave. So tell me, guys, who will issue valid? Who will issue valid? Okay, master ready. Fine. Slave will issue valid because slave is the component who needs to give the information to the master, right? Slave is the component who is issuing the response. So slave will issue valid. Slave will issue. Master will issue ready. The valid need to issue by the slave. Master need to issue ready. Okay, got it, guys? Did everyone got this, guys? Okay. Say this. B handshake. Now, read address channel. Read address channel. Master, slave. Now tell me who will issue like who will issue it? Okay, two responses. Master valid, slave ready. Fine, master valid, correct. Master valid, slave ready, correct. This is AR valid. Okay, this is AR valid. AR valid. AR handshake. So now let's see the last handshake. Master, slave, read data and response channel. Now tell me guys, who will issue who? Master ready, slave valid. Exactly. This is R valid. This is R ready. That's it. Done. R handshaking. I hope everyone got this. Right, exactly. Master slave. Slave valid, master ready. Exactly, correct. I hope everyone got this. How the handshaking is happening. Any doubts here, guys? Any doubts here, guys? Okay, so I will end the session today. So in next session we will start the signals. So each channel has a dedicated signal. So we will go through that each signal and what is the importance of the signal, how much wide that signal is, okay, and how to handle the signals, what and all are the importance of the signals and everything. We will see that. Okay? So before ending the session, any doubts, guys? Any doubts? If there is doubts, please ask, or else I will end the session. Okay, okay, fine. No doubts, then I'm ending the session. Thank you, guys. Thank you very much. We'll meet in the next session.
This conference will